Good evening. We are going to solve the same problem, that is by stiffness method. Now we have in stiffness method, this value is EI. We have this 2 EI, same values we are taking. And then we have this as 3 EI. Now we will start with step 1, same as slow deflection method, kinematic indeterminacy. Kinematic indeterminacy. We have Gk is equal to 3. That is theta B, theta C, and delta. Then we have step 2, fixed end moments. So we have MFAB minus WL by 8 minus WL by 8 MFBA WL by 8 so we have 45 MFBC minus WL square by 12. So minus W L square by 12 MFCB WL square by 12 MFCD minus WAB square upon L square minus 22.5 MFDC WA square B upon L square (7.5 kilonewton meter). Now we have step 3, stiffness coefficients. Now we have first, so we have 3, so we will say theta B number 1, theta C we have number 2, and delta we have number 3. So now we will start with, we will apply theta B equal to 1. So theta B equal to 1. So this also we have theta B equal to 1. So we have with this 4 EI by 6. This will be 4 EI, we have 2 EI by 5. Here we have 2 EI, so 2 EI by 5. So we have, this will be 1, 2, and 3 we have over here. So we have this as 4 EI by 6. This is 2 EI by 6. Here we have RB. RC we have 0 because we do not have any moment over here. And now we will go with, so now we will have different names to the joint. So we have this will be S1, this will be S2, and here we have S3. Now we have applied theta B1 and it has number 1. So we have S11, then S21, and then S31. So S31 we have RB plus RC. This is RC. Now S21 directly we can have 4 by 5.8 EI theta B. EI, sorry. And then S11 we have 4 EI by 6. So we can write 2 EI by 3. And then plus 8 by 5, 1.6 EI. And then if we will solve this, we will get 6.8 EI upon 3. This is value of S11, S21 0.8 EI theta B, S31, RB plus RC, RC 0. RB we will get it as RB equal to 6 EI upon 6 square, and it will be EI by 6. As it is towards negative direction, so it is minus EI by 6. So this is when we are going to apply unit displacement, that is for theta B. Now we will apply unit displacement to theta C, and then we will see what values of stiffness coefficients we will get in second one. So now we will have this. So now we will go for a unit displacement, which is theta C equal to 1. So we will get it like this. So we have theta C equal to 1. And here also we have theta C equal to 1. So we will get over here. So we have seen we have 4 in bracket 2 EI by 5. And here we have 4 in bracket. Now here we have 3 EI by 4. And here we will get half of this, which is 2 in bracket 2 EI by 5. Now when we will go for third displacement values, then we have values 0 over here. So our RB becomes 0. And then we have that is RC. So we have this value, that is 4 EI, 3 EI. We have this value, half of this 1.5 EI. And then these are clockwise. So to balance it, we have RC anti-clockwise. And we have RC equal to 4.5 EI divided by 4. 4.5 EI by 4. So because 3 plus 1.5, so 4.5, and divided by 4. So we have this value, that is 4.5 EI by 4. Now we will switch over to the next part, in which we have to go for the values of S11 and all this. So we are here S1, S1. Here we have S2. And here we have S3. Now we have displacement applied at 2. So we have S12, S22, and S32. And again, we have this as RB plus RC. And then from this, we will get it as S12 4 EI by 5. So 0.8 EI. S22, if we will calculate, we have this value 8 EI by 5. So 8 EI by 5 plus 3 EI. So we have this as 15 plus 8. So 23 EI upon 5. And as 3 to we have minus 4.5 EI by 4. Because RC we have towards negative, so we have this value. And then we will apply for third. We have third, that is delta, we have to go 1. And that we will apply. And then we will write the values, that is ADL value. Then we have to write FD values. So now we have next apply unit displacement. Now, while applying unit displacement, then that is independent of beams. Beams will not participate in this. And then we have to apply unit displacement. So we have this now will be straight. I already explained yesterday. And then we have here again 0. So we have 6 EI delta and L we have 6. So 6 square. Now here we have to go in this fashion again. And then we have 0 over here. Here we have 6 EI, we have 3 EI upon 4 square. Then we will have to make it separate. So we have value over here. Now this 1 6 gets cancelled, so it will be EI delta by 6. This also we have EI delta by 6. And then we have now this is this we have anti-clockwise. So we'll just rub the arrow because we have this arrow that is anti-clockwise. And therefore reaction should develop clockwise. So I will draw this. So we have clockwise. We have anti-clockwise actually. And reaction should develop clockwise. So we have this value of RB in this direction. Similarly, in the same way, we have RC also. These values are anti-clockwise. Now you can see what will be this value. So 9 by 8 EI. And then we have this will be 9 by 8 EI. And the same we have on this side. Again anti-clockwise 9 EI by 8. And here we will get RB, therefore we will get that is EI delta by 6 plus EI delta by 6, 2 EI delta. So we have EI delta by 6 plus EI delta by 6 divided by 6. And then from this we will get value of RB that is equal to EI delta by 18. And then RC, we will get it as RC equal to 9 by 8 EI plus 9 by 8 EI and divided by 4. And from this we will get value of RC, that is equal to, so we have 9 by 4, 16. So we have 9 EI by 16. And then if we will add this, then we have these values now that we will write actually. So now we will go to this color last. So we have here now S at 1, S at 2, and S at 3. Now we have applied delta 1, so 3. So we have S1, 3, we have S2, 3, and then we have S3, 3. And from this we will get S1, 3 equal to minus, because anti-clockwise, EI by 6 delta. Then S 2, 3, we have again minus 9 EI by 8, sorry, no delta. And then as 3, 3, we will get it as EI delta by 18. Sorry, EI by 18, no delta. Delta is 1. So delta is 1. And then plus 9 EI by 16. And then from this, we will get it as, we will have 9, 9, then we have 8, 72, so 144. So we have 8 over here, and we have 9 over here. 9 nines are 81 plus 8, so we have 87 EI by 40. And then now we have all values, then we will go with next step. So we have step number 4, formation of equations. And then we have in formation of equations, we have FD equal to FDL plus S into D. Now all FDs are 0 because we do not have any load at the joint. In last example where we have this type of problem, then we have this will be at third, and we got this value as FD, and that we have substituted as 10 kilonewton. Here we do not have any value likewise, so we have this as FD. Now we will go FDL1. FDL1 is equal to M. So at joint B, so we have MBA plus MBC, that is equal to MBA, we have 45, and MBC we have minus 104.17. And from this we will get this value of FDL1, and that we will get it as 59.17. So minus 59.17. Then FDL2 we have MCB plus MCD. MCB we have 104.17 minus 22.5, and we will get this value 81.67. Now FDL3 we have RB plus RC, and we have to calculate this value now. So we have this load that is 60 kilonewton at the center. So we have this as clockwise 45. This we have, that is fixed end moment. This is anti-clockwise 45. And therefore we will get reaction equal half of, because this gets cancelled. We have this as 30 kilonewton, 30 kilonewton. And then if we will go to another, then we have this as This is 22.5. And then we have on this side, that is clockwise, 7.5. And then we have value over here, that is 40. And this is 1. Therefore, we will get this RC, and this is 3 meter. So we will get RC into 4 clockwise minus 22.5 plus, sorry, anti-clockwise, then we have plus 7.5 I can write, minus 40 into 3, which is equal to 0. And from this we will get RC, that is equal to, we have minus 22.5 plus 7.5. So this is minus 15 minus 120. So minus 135 upon 4, which will be 4 threes are 12. Then we have 3, then 7, 5. And then if we will put one we have towards plus, another we have towards minus. So we have this as 30 minus 33.75 equal to 3.75. And now we will write equation FD1 equal to FDL1 plus S11 D1 plus S12 D2 plus S13 D3. Now I will write all equation fast. So we have 0. And FDL1 we have minus 59.17 plus S11 we have 6.8 EI upon 6.8 EI upon 3 theta B plus 0.8 EI theta C minus EI delta upon 6. And then you can see we will get this first equation, that is same if we will go to slope deflection 6.8 EI theta B upon 3 plus 0.8 EI theta C and then minus EI delta by 6, and that is equal to 59.17. Then we have FD2 is equal to FDL2 plus S21 D1 S22 D2 plus S23 D3. And then if we will take FDL2, or we will write 0 equal to FDL2, we have 81.67 plus we have 0.8 EI theta B, then plus 4.6 EI theta C, and then minus 9 EI delta by 8. And from this we will get second equation 0.8 EI theta B plus 4.6 EI theta C minus 9 EI delta by 8, which is minus 81.67. This is equation B, this is A, and then we have equation C, FD3 equal to FDL3 plus S31 D1, S32 D2, and S33 D3. And then from this we will get, now I will directly write S31 we have, we can see S31 we have minus EI by 6. So we have minus EI by 6 theta B. Then S32 you can see, so we have 3223 same, minus 9 EI by 8 minus 9 EI delta minus 9 EI by 8 theta C. And then we have as 33 we got 87 EI upon 144 plus 87 EI upon 144 delta and that is FDL3 we have 3.75. It will go on other side, becomes minus 3.75. So same equation, solve this, we will get same values, that is of EI theta B. So I will write that values over here again. So solving this equation, we will get EI theta B equal to 35.47, EI theta C equal to minus 41.58, EI delta equal to 72.18. And then by using slope deflection equations, we can find final moments. So we will stop here only. Remaining part we will see in the next lecture. So thank you.